All right, guys. So 10.1 was talking about chords, secants, and tangents, but now we're going to move on to talking about arcs. So these are more of those vocabulary words from that circle vocabulary page in your notebooks. Okay, so we're going to be talking about major arcs and minor arcs and semicircles, as well as central angles. Okay, so this first page is a little bit of reading, so I'm going to explain as I read. Okay, so a central angle of a circle is an angle whose vertex is the center of the circle. Okay, if you don't know what a vertex is kind of like the corner of the angle. Okay, so this is my angle. That piece right there that I'm pointing to is the vertex. Okay, so an angle is called a central angle if that corner is in the very center of your circle. In this diagram down here, angle ACB is a central angle because its corner is angle C right there in the middle. If the measure of this angle is less than 180 degrees, then the points on circle C that lie on the interior of angle ACB form a minor arc with endpoints A and B. Let me get a different big bolder color here. What that's saying is if this angle is less than 180 degrees, then the part of the circle that connects the endpoints is called a minor arc. Okay. The points on circle C that do not lie on the minor arc AB form a major arc because it will be bigger than 180 degrees. So that's the rest of this circle, and I know I'm not drawing it perfectly round, but the rest of the circle would form a major arc. Okay. A semicircle is a type of arc where the endpoints are the endpoints of a diameter. So let me draw an example of a semicircle. Okay. So here's the center. The diameter goes from one edge to the other, right through the middle. Now let me get, this is, oh, I should have not changed quite. But this is A and this is B. Then a semicircle is going to go from A to B, the endpoints of my diameter. So this is a semicircle. Okay. So we're talking about the piece of the circle that connects the endpoints of your angle. Okay. So minor arcs are named by their endpoints. The minor arc associated with the angle ACB in this picture right here is just named arc AB with that arc symbol above the letters. Major arcs and semicircles are named by their endpoints and a point on the arc. A major arc associated with angle ACB can be named ADB. So one way to remember is minor arcs are using 2 letters. Major arcs use 3. And semicircles use 3. Okay. Let's talk about measuring arcs now. So the measure of a minor arc, which means how many degrees is the measure of its central angle. So whatever angle is in the middle there, that's how big a minor arc is. So the expression M and then arc AB is just read as the measure of arc AB. So that little M right here means measure. The measure of the entire circle is 360 degrees. So that means that the measure of a major arc is the difference of 360 degrees and the measure of the related minor arc. The measure of a semicircle is always 180 degrees. Okay. So let me get my colors out here again. So in this picture right here, here is a minor arc. And it is 50 degrees because that's how big the angle straight across from it is. Okay. From A to D to B is the major arc that is associated with this minor arc. Whenever you have a minor arc, you will also have a major arc. They come in pairs. Okay. The measure of the major arc is just 360 minus 50, which leaves us with 310. So let's practice finding some. So let's find the measure of each arc of circle P, where RT is a diameter. Okay. If RT is a diameter, it means it's cutting our circle in half, which tells us a little bit about how many degrees are in some of these pieces. Okay. But it wants us to find first the measure of arc RS. So I'm going to use some different colors here to represent those. So let's find RS. So from R to S, that's definitely a minor arc because it's not a full half circle. Okay. So measure of arc RS is just going to be however big the angle is. That angle is 110 degrees. Okay. And I didn't ask for this, but I'm going to write that this is a minor arc. You can tell because it's less than 180, but you can also tell because it only used 2 letters to name it. Okay, let's do next one, RTS. So from R to T to S, it tells you the order you should go in. That's the rest of our circle, right? So I can figure this one out by taking 360 degrees and subtract 110 degrees, which leaves us with 250 degrees. And this is a major arc. Now the last one. Now it's similar to B, right? RTS. This one is now RST. So I'm going to go kind of on the outside here so you can still see my color. So from R to S and then to T. Okay. So we don't know how big this little section inside here is. But we do know that this is 110. But we also know that this line that goes through the center is a diameter, which means it cuts my circle completely in half. And half of 360 is 180 degrees. This is a semicircle. Whenever you're finding the arc using a diameter, you're always ending up with a semicircle. Hey, let's move on. So, 2 arcs of the same circle are called adjacent arcs when they intersect at exactly 1 point. You can add the measure of 2 adjacent arcs. Okay. Sounds, if I don't know if you can hear this, there's a giant airplane very close to my house. Okay. So, we've seen that word adjacent before. We saw it when we talked about adjacent angles. We saw it when we talked about the adjacent side. Adjacent just means next to, right next to it. So you can add arcs that are right next to each other. Okay. So number 2, it wants us to find the measure of each of the following arcs. The first one is GE. So from G to E, okay, this is less than a semicircle. This is a minor arc, which means I'm just looking at adding up those angles that are inside. I'm really just adding up those two right there, which is 40 plus 80, or 120 degrees. Okay. The next one, GEF, we can already tell that this is either a semicircle or a major arc because it has 3 letters. But now I'm going from G around to E and then around to F. Okay. So all I need to do is add up those angles on the inside there. So I want to add up 40 plus 80 plus 110, which is 230 degrees. And then last one, GF. So this is different than B because I'm not going around the long way. I'm going the shortest possible way between G and F. Okay, because this is a minor arc, it only has 2 letters. I want this piece right here. Now this is the only angle that we don't have a measure for, right in here, right? But I know what the rest of the circle is, so I can find out how big this piece is. The whole circle is 360, and the part that I already know, which is really that pink part, is 230. So if I do 360 minus 230, it will tell me this green section. Okay. 360 minus 230 is 130. 130 degrees. And we can go through and list them as major or minor or semicircles based on how big they are. So if you want to do that practice, go ahead and label those as either major or minor arcs. Okay. Number 3, a recent survey asked teenagers whether they would rather meet a famous musician, athlete, actor, inventor, or other person. This circle graph shows the results. Find the indicated arc measures. So what's nice about this picture is they tell us all of the measures in here. Okay. So first one is the measure of arc AC. So from A to C, I know that it's the short way around, not this longer way around, because it's 2 letters. Okay. So from A to C, that means I'm adding up this pink section plus this blue section. So that's 29 degrees plus 108 degrees, which is 137 degrees. And I can add them up because they are right next to each other. Next, it wants the measure of arc ACD. So from A going around, let me redo that one. A going around to C and then to D. That's just the pink, the blue, and the yellow now. So we have 29 plus 108, now plus 83. Okay. That is 137 plus 83. Kind of doing this in my head. That is 0, 1, 4, 2, 220. Okay. C now wants us to find ADC. So from A to D to C, that's the purple, the green, and the yellow. So 79 plus 61 plus 83. $223. And then last we have measure EBD. So from E, this is going to do my best to make sure they don't overlap, to B all the way around to D. So really that's a big arc, right? The only section that's not included in there is that green one, the other. So we're adding up all of the other sections. We've got 79 plus 29 plus 108 plus 83. I get 299. And that's it. Moving along, number 4, identify the given arc as either a major, minor, or semicircle, and then find its measure. Whoops. Hey, so the first one, letter A, find or label arc TQ. So from T to Q, there's a lot on here, so I'm not going to do the colors. I'm going to run out of room here. But between T and Q, remember this is a minor arc. Either you can look and see it has 2 letters in its name, or if you look at the picture, that piece is less than 180 degrees. It's actually just 120 degrees. Letter B, from Q to R, all the way over here to T. Okay. I know that that's either a semicircle or a major arc by the 3 letters, but if I look at the picture, that shows me that it's just a major arc. It's bigger than half a circle. Okay. How do I figure out how big it is? Well, the only thing I really need to find before I can figure out the measure is that missing angle right here. Okay. So to find this piece right here, I'm just going to take that I know there's a 360 degrees in a circle, and I'm going to take out the ones I already know. So 120, 60, and 80. and we get 100 degrees. So now to find from Q to R all the way over to T, I'm adding up these three right here, 80, 60, and 100. It's 240 degrees. Next is TQR. This one I am going to outline just so we can see. If I'm going from T to Q to R, then T and R actually form a diameter through the middle of this circle. So this is a semicircle. And I don't even need to look at the picture to know how big that is. They are always 180 degrees. Next is Q to S. Now, how do I know I'm going this direction rather than this one? It's only 2 letters, so I know it's going to be the shorter way. So what's the shortest way to go from Q to S? It's this one right here, with R in between them. So I just need to add up those two arcs, which is 60 plus 100. It's definitely a minor arc, and it is 160 degrees. Next, we have TS, 2 letters. That's a minor arc. Between T and S, there's just one angle, and it's 80 degrees. And then finally, RST. So from R to S to T, okay, that's the other half of our circle, right? Use a different color here. R and T are still the endpoints of our diameter. Whoops. So this is a semicircle. And it is always 180 degrees. Okay, last page. We're going to talk about 2 theorems really quickly. The first one is called the congruent circles theorem, and it says that 2 circles are congruent if and only if they have the same radius. So pretty easy. 2 circles are congruent if they have the same radius. Second theorem, the congruent central angles theorem. This theorem says that if you are in the same circle or in congruent circles, then 2 minor arcs are congruent if and only if their corresponding central angles are congruent. So the only way for arcs to be congruent is if those central angles are congruent. So this next set of examples, we want to tell whether the red arcs are congruent in the picture. Explain why or why not. So number 5 we have is CD, this first red arc, congruent to EF, this one over here. These 2 arcs are in the same circle, so really I just need to see, do those central angles match? This one's 80 and this one's 80, so yes, they are congruent because the central angles match. That only works if they're on the same circle or in congruent circles. Let's look at number 6. So number 6, we have a circle within a bigger circle. So it wants us to see is RS the same as TU. Okay. So these 2 arcs are not a part of the same circle. They're 2 different circles, even though one's inside the other. So they're not on the same circle. Are they on congruent circles? Is this circle on the inside the exact same size as this one out here? No. So even though they have the same angle in the middle, right? This 90-degree angle, it goes for RS and TU. Even though that matches, these are not congruent. Okay. And our explanation is they're not on the same circle or congruent circles. Okay. Now number 7, UV and YZ. So first we need to check, are they either on congruent circles or the same circle? Well, they're definitely not on the same circle, but are these two circles congruent? The way we can tell is, do their radii match, or is the radius the same thing on both circles? So let me highlight here. This is the radius, and this is the radius. And you can see it has a little segment in it which shows me that yes, these are the same. So they are congruent. So now I just need to check, do the angles match? Well, this one's 95, this one's 95, so yes, they have the same central angles. Number 8 is very similar to number 7, right? Wants us to see is AB and CD congruent. So I first need to check, are they on the same circle or congruent circles? They're not on the same circle, but this radius and this radius are the same. So these circles are congruent. So now I just need to check, do the angles match? Here's 145, here's 145. Yes, they are the same size. So they are congruent because the central angles match. And then finally, number 9, MN and PQ. So first we need to check same circle or congruent circles. They're not on the same circle. Are they congruent? This radius is 5 and this radius is 4. These are not congruent circles. So I cannot say that those arcs are the same. So no, it's not on the same or congruent circles. And then the very last theorem, similar circles theorem, all circles are similar. Remember, similar means same shape, different size. And that's it for 10.2.